Okay, here we go. So now we get to do everybody's favorite is word problems and how do we apply this whole graphing and shading and what's it all mean. So I'm going to walk through this process on one of the problems that you're going to see. Obviously, the numbers are going to be different, so always watch for that. But I wanted you to see it live as I walk through it so that you can see the process that's needed. So let me share my screen and get the right problem here. Okay, so this is again section 5.2, and now you have a word problem. So with a word problem, the first thing is don't panic, okay? With these, you always want to set up a table, if you will. What it does is it organizes the information, okay? So I'm going to set up my table by, let me move this out of the way here so I have more room. Okay, so I'm gonna set up my table by kind of just reading through the information and writing down the information that I think I'm gonna need. So a manufacturing company makes two types of water skis. The first type is the trick ski, and the second type is the slalom. So trick and slalom. Okay, the trick ski requires 11 labor hours for fabricating. So all that means is it takes 11 hours of labor to fabricate the trick ski and 1 labor hour for finishing. So we have two things that we're looking at, right? In a business, you're going to have this where you have, there's different stages of production. So we're going to only look at the fabricating and the finishing. So notice how I have this set up. I have the two things that we're looking at here, and I have the two things that we're going to get information on here. So do you see now I have a chart? Okay, so it's not super involved. Okay, there's going to be one more column here. So it just set up a 1, 2, 3, 4 column and 1, 2, 3 row chart. Okay, so now we can start filling in the information. So the trick ski requires 11 hours for fabricating and 1 hour for finishing. So do you see it? Fabricating 11 hours for trick ski, finishing 1 hour for trick ski. The slalom ski requires 7 labor hours for fabricating and 1 hour for finishing. So fabricating 7 hours slalom, finishing 1 hour slalom, okay? The maximum labor hours available, okay? So maximum, that means I can't go higher. So what that means is it's got to be less than or equal to these amounts. Okay, so for fabricating and finishing are 154 and 18 respectively. So what that means is I only have 154 up to 154 hours for fabricating, and I only have 18 hours for finishing. So in a business setting, you only have so much time, so many workers, so much material. Maybe your machines can only do so much in an 8-hour day. So that's why there's restrictions. So that's what this restriction is. We only have 154 hours or less and 18 hours or less. This is the most that we can do. And then the question is, find the set of feasible solutions graphically for the number of each type of ski that can be produced. Okay, here is the important part. Well, all the numbers are important, but this is very important. If X is the number of trick skis, so X is the number of trick skis, and Y is the number of slalom skis. So Y is the number of slalom skis. Write a system of linear inequalities that indicates appropriate restraints on X and Y. Okay, so the appropriate restraints are for a trick ski and for fabricating, I can have 11 hours for trick skis, 7 hours for slalom skis, and I have to make it less than or equal to 154. That's my fabrication equation. The finishing equation is I can have 1 hour for the trick ski and 1 hour for the slalom ski, and I only have up to 18 minutes, or I'm sorry, 18 hours to use. So here's my system of equations, okay? Now you are right back to what we did prior. You have your two inequalities. We know we are only working in the positive because in business, you aren't going to deal with negative trick skis or negative numbers or negative hours. So this graph is already set up in your first quadrant. Okay, it's already set up, so you don't have to worry about the, that's what you're not looking at the whole graph. You're looking at just that first quadrant. Okay, so your job then is to come over here and you're going to fill in your equation. And this is for your symbol. They're giving you a choice: greater than, less than or equal to, less than or greater than or equal to, and we are doing less than or equal to 154. And I'm going to check my answer. Good job. Now I'm going to write an inequality for the constraint on finishing. So finishing was the second one. So x plus y, and then again is less than or equal to 18. And then I'm going to check my answer. Okay. Now, are there any other inequalities needed? Well, there are, because if you look at this graph, this graph only looks at the positive x and the positive y. So we have to have, yes, x is positive, right? All numbers greater than or equal to 0 are positive, and all numbers of the y greater than or equal to 0. Okay, so make sure you read your signs. You always read your signs from left to right. So if you see the bigger sign or bigger open first, that's your greater than. Check my answer. Okay, now we're going to graph it. Okay, so now we're going to walk through that process of graphing, and you're going to graph it on paper, and then you're going to input it on your MyMathLab. Okay, so when I graph it on paper, it's going to look like this. Again, I'm going to use two different colors. So I have, this one is going to be my green one, and this one's going to be my purple one. So the green one using cover up, right? So I'm going to cover up my 11x, and I end up with 7y equals 154. So hopefully you're watching and you are doing this the exact same steps. So y is 22, and then I'm going to cover up the y and solve for x. So I have 11x equals 154. So 154 divided by 11 is 14. So my y value is 22, and these are all by ones. My x value is 14. So there's my green line. And you're gonna pretend like that's straight. Oh man, hang on. Let's try. Oh, aha, here we go. I can actually do a straight line. Look at me go. Okay, now I need to do the test point, right? 0, 0, 0. Oops, the draw. 0 is less than or equal to 154. This is a true statement, so I'm going to shade down here. Okay, so it's all green down there. Now I'm going to do the same thing with my purple. The purple line is easy. There's no solving. It's cover up one, I get x equals 18. Cover up the other, I get y is 18. I come over here, here's my 20, 19, 18. Here's 14, 15, 16, 17, 18. Pick up my line and connect the two. Okay. Now I'm going to do my test point. 0 is less than or equal to 18. This is a true statement. That means I'm going to shade below. Okay, so you can see this in here, let me get it in red. This in here is my feasible region. Okay, I have a corner point here. I have a corner point here. I have a corner point here, So where the green and the purple intersect, and I have a corner point here. Okay, so when I go to graph it, I know I already see where it's shaded. I have my X and Y intercepts. Let me erase part of this so I can see what I'm doing. So that chart's going to be really important. And this is why it's important to do this on a piece of paper, because then you don't have to erase anything. You have it sitting there looking at you. All right, so if you remember, we're always going to do our X and our Y first. So I have a solid line, pick up my tool. I'm going to put a point anywhere on the Y, click it again, and there's my, X is greater than or equal to 0. Do the same thing for my Y is greater than or equal to 0. Click again, becomes blue. Now I'm going to graph my two lines. The green line, I had a point at 22 and 14. Click again, makes it blue. The purple line, I had a intercept at 18 and then again at 18. And again, notice the number that's up here. When I put my cursor there, it gives me the coordinates. Okay, I want to click again. Okay, now I'm going to shade. I know the shading is in this area here. And again, because I have that X and Y intercept, or X and Y is greater than or equal to 0, it locks it in. Now I save it. I check my answer. Well done. And use the graphing tool to represent the correct solution. Oh, only once. We already did it. Okay, we're good to go. So this is where, this is where you can do these over and over and over again. Do you see down here it says similar equation? When I click on that, let me get all my writing off of here. When I click on that similar exercise, do you see how it sets it up again? Different numbers, exact same setup. Okay, and you can do that over and over and over and over and over again until you feel so comfortable with this. Okay, all right, I'm going to stop there.